Hi, welcome to my YouTube channel Vaishnav 360. Like, share, subscribe, and do not forget to hit the bell icon.
Hello guys, welcome back to my channel. This is Vaishnav and we are going to do Maths 1B chapter number 1 Locus. Now, before explaining you what is locus, now I am going to tell what we call a locus as and how it is represented in a diagrammatic form. So before seeing those, we'll read the note. That is, a line is made up of several points. There are so many points which forms a line. If the line is not ending or it is extending, then the points are increased. I will tell you an example. Here, wait. Here I will draw a line. Here it is a line which extends till the end. Okay. Now, till end means where? There is no end for a line, right? So, as the line extends, there is more number of points. From here to here, there is a particular number of points. Now, if this line here is now what do you say, extended, right, or expanded. Now, if it expands, we will take till here. If it expands till here, there is a particular number. But I have written that it is unending. It is a line which never ends. So there are infinite points. Okay. Now let me tell the explanation of the diagrammatical form of locus. Now here this is a main line. Okay, where from here to here it is 4 centimeters, and from here to here it is 4 centimeters. Okay. Now there are particular points which are drawn 1 centimeter before it. Okay, this is a 1 centimeter, this is 1 centimeter, this is 1 centimeter, and same as here 1 centimeter till the end. Okay, now if we take these two ends and extend here, we will get a point that is P. Now this point this line, that is AP or PA, and this line which is PB or BP is equidistant, because here it is 4 centimeters and here is also 4 centimeters. Let us take here a point that is O. A to O and O to B are equal, that is 4 centimeters. Then if we take a point exactly 1 centimeter above and we check the distance here, we will get 4 centimeter. So then we will call this point P, this point as a locus. Okay, same as here we have took here a point Q which is 2 centimeters from this. If we take this point and join this point and take this point and join this point exactly the point where it is connected to Q, when where the B is, and Q are connected, then we can find it that these both are also equidistant lines. So through this we can convey that these 2 points and same as this point is also an locus. This line extends till infinity, right? Like this. This line extends till here. This line extends like this. We can do so many n number of locus through this. We can take this line here, this line here. For your explanation, I have drawn a line for 1 centimeter and 2 centimeters. But we have n number of points here. So if we take this is a point, we can draw a line from here to here and tell it is a locus. Okay. Now Let's see the circle here. This is a diameter. Okay. In this diameter, from here to here, that is AP, is a radius. Okay. From this point, if we take Q, if we take R, if we take any some other point, we will take X, X, Y, Z. Okay. If we take here X, Y, Z also, they are same. Let's assume that this is 4 centimeters. Okay. Then this should be also 4 centimeters. This should be also 4 centimeters, and etc. Here we'll get 4 centimeters, 4 centimeters, and every radius in this circle will be 4 centimeters. As you have learnt in the lower classes that the diameter is the twice of the radius, and the radius is the way we will draw a circle. By a compass, we will take 4 centimeters here and rotate it so that we can get a circle. But here is the point where we get a locus, because any point from here to here is 4 centimeters, and any point from here to here is 4 centimeters. Now we can convey this as a locus because any point which is extended till the end of the circle, or till the circumference of the circle, we will get the same distance, that is 4 centimeters, 4 centimeters, right. Now we can convey that it is a locus. Now we'll check here. We have a main line here and these two separate lines. Okay. Now if we take this line, the difference between this and this line is 3 centimeters, and it is parallel to Q. Then here we'll get that, according to my side, I think you all may get this concept, because if this is 3 centimeters above and parallel, then if we take this point, it is 3 centimeters. If we take this point also, from here to here, we will get 3 centimeters, right. Now if we take till this end and till this end, we will get 3 centimeters. Through this we will know that this is equidistant and it is a locus, because in every point we can check and see that the distance from here till here is 3, same as here it is 5, and it is parallel. Then if we take from here to here, it will be same, that is 5 centimeters. So here we will end with the diagrammatical explanation. Now we will check out the original definition of this, through which you may understand now. Okay. Now here, locus, the set of all points satisfying given condition or given property, is called a locus. This satisfies, right. Here we have an example. I have explained this already, no? All points. From here to here, there are infinite points. If we take this point, this point, this point, or this point, we will get same distance, that is 4 centimeters. Right. So we can convey that this is a locus. I think you may all understand. Let us take few more examples for understanding it better. Now here, the first example. Let us take point A and B, which is x1, y1, which is the point A, and x2, y2, which is the point B, which are 2 points. Then the set of points equidistant or equidistance to A and B is a locus. Let us take point P, which is the point where we connect A and B. Okay. Now let P be a point on the locus, and we will get the condition, that is PA is equal to PB. Now what I explained here? Here I explained that this is P point, right? This is P point, okay? Point P. This is A and B. Let us take the same question, same example which we have down. Here A and B, and if we draw a same line connecting to each, we will get this point as a locus. Then this and this are equal, right? So if we check here, the given condition states true. Okay. Now let's go to the second example, right? Or we can say that theorem or example, we can say. For me, it's an example because in every what do you say problem, we use this as a skill or trick to solve this problems easily. Okay. Now here example 2. The set of points in a plane which are at a constant distance from a fixed point is called a locus. Now here we know that I have explained this diagram here. This is a fixed point locus, right? And this is 2 points which connects the point here P locus. Okay. Now this explains what do you say? We can form a locus by example number 2 also, right? Okay. Let P is xy be a point on the locus. What did I explain right now? P is a point. Okay. Point locus. P is a point. Let us take uh, this, right? If we should find the equation of this, or we should know what is the distance of this, then we should connect this and this. Okay, this and this we should connect, and through distance formula we will do this. I am going to explain the distance formula. Wait a minute. Right, first I will explain this and explain you. PC, here given condition is PC is equals to R. What is R? This line is R. Here not only PC, we will have two conditions, that is PC, right? Here we will take B. Okay. Here PB and PC are equal. If we take PB and PC and solve through distance formula, we will get R, right? Now here mainly we can take these two and check from the origin point to the C, which is R. Okay. Now we'll get the equation of this total line if we use the distance formula. But if we want this till here, we will take this example and solve. Okay. Now I think you might all understand. Let me repeat all the introduction again from the starting. We have more definitions, and we have a main important formula which is the key source or the main formula which is used in each problem in the exercise. First we'll recollect all the matter which I have made or I have explained you right now. Okay. People who can copy or take a screen or can take screenshot for the further use of this. Okay, people can note down, right? Who are watching now, people, please note down or take a screenshot so that it will be helpful for your further chapters or in the further life. Okay. Now locus. What is locus? Locus is the set of all points satisfying given condition or given property. Okay. Now to understand what is locus, we have these three diagrams, right? You might see these three diagrams we have. Okay, now we have a line which has several number of points, right? So if we take a point here, a point here, we'll get the same length or or when the point here gets connected from here and here, we'll find out that this and this point which is connected to this point are equidistant, right? I hope you may all understand what I am saying to you or telling to you. Now here we have a circle, right? From this point, if we connect any point in the circumference of the circle, it is a locus because we get the same length from here to here, here to here, or here to here. Okay. Now we have another diagram, right? In this diagram, we have, check this out. Yeah, this is a parallel line which always goes parallel to this line, right? If we take from this point to this point, it is 3 centimeters. Then from here till the end of this line or line segment, we'll get equal distance from here to here, right? Same as the down one, Q and R. Okay, this and this are parallel, and if we take from here to here or here to here, the length from Q and R are equal till infinity or till the end of the line. Okay, now we are going to do again the examples. Yeah, now here example 1, let A is x1 y1 and B is x2 y2 are 2 points, then the set of points equidistant or distance to A and B is called a locus. Let P, which is x and y, be a point on the locus, and the given condition will get it as PA is equals to PB. Now, the second example, which is the set of points in a plane which are at a constant distance from a final or fixed point, is called a locus. Let P, which is x comma y, be a point on the locus, and the condition we'll get is PC is equals to R. Right. Let's go forward to the equation of the locus. Right. Now we are going to learn what is equation of the locus. Okay. Now write equation of the locus. An equation xy is equals to 0 is said to be an equation of the locus if every point that satisfies x comma y is equals to 0 is a point on the locus, and every point on the locus satisfies f of x comma y which is equals to 0. Okay, here the equation is said to be 0 when it is a point on the locus, right? Or uh, or we can say it is a equation of locus if every point uh, which satisfies that the equation or the point, what do we say, P, we will take P as a point right here, P is a point here, also P is a point, P is equals to 0, then it is a point on the locus, right? As we took an example of the diagram here, let's draw it again. This is point P. Here there are so many points from here till here, right? This is A and B. Okay, if this point satisfies what do you say, this line of equation or this line satisfy that this point is P, this point is P, or this point is P, then it is a point on the locus, which is, now here I mentioned here p because I have took here p. If there are there is p here or p anywhere here, then if it is 0, it is equal to 0, then the what do you say, coordinates or the point p is a point on the locus. Okay, now here the note, if p, that is x comma y, be a point such that ax1 plus by1 plus c is equals to 0, then equation of the locus is ax plus by plus c is equals to 0. Here this note is conveying that here if the point P is like this, what do we say? Uh, ax ax1 plus by1 plus c is equals to 0, which is the general form, means this is multiplied, right? Okay, a into x1 is multiplied, b into y1 is multiplied, and c into 1 is multiplied, okay, which is equals to 0. We should convert this equation to a general form, that is ax plus by plus c is equals to 0. Okay, I hope you might understand. And this is the very important formula which is used in every problem in the exercise number 1a. Okay, which is the distance formula, right? Here the distance formula is x1 minus x2 whole square plus y1 minus y2 whole square, which is in the under root, that is square root. Okay, let me read it properly. We will call it as under root or square root x1 minus x2 whole square plus y1 minus y2 whole square. Now here ends the introduction of the following locus. Now we will go deeper into this lesson and solve the problems of exercise 1a. Okay, now here exercise 1a, first problem in the first Roman. Okay, now the question here is, find equation of a locus of a point which is at a distance of 5 centimeters from, or 5 centimeters, or any unit we will take it as unit. There is there is not mentioned in the question if it is 5 centimeters or 5 meters. Okay, so we'll take 5 units from the point a, which is 4 comma minus 3. Now here we are going to solve this problem. Now let us write what is given first. Given here is a is equal to 4 and minus 3, and we'll take a point. Let P be a point, uh, be a point, that is x comma y. Okay, now here if we check out, we have uh, the point of locus, which is PA. Okay, now PA, we have the condition, right? We have learned the condition before in the introduction. Here condition, given condition, here given condition is P and A is equals to 5, right? Now if we check, we have to use here PA, which is the distance formula. Now what is distance formula? We should find out PA. What is PA? PA is under root, what is distance formula? What did I say? That is x1 minus x2 whole square plus y1 minus y2 whole square, right? Now if we will take uh, if we will take the original values here, we will get the answer. Now we will take original values, right? Now here x1 is x no and minus x2, right? Let me mention or you will get confused. Here in the point P, x is x1 and y is y1, and here in point A, 4 is x2 and minus 3 is y2, right? Now here x2 will get it as 4 whole square here, plus we'll get y1 is y and minus 3, right? Minus into minus plus 3 whole square. Okay, this is PA. Now to remove square root, we'll take squaring on both sides. This is a short form of squaring on both sides, right? Now PA square is equals to under root x minus 4 whole square plus y plus 3 whole square. Okay, this totally is under a whole square. PA is what? This value, means this value, and PA square is this value whole square. Now to remove the root, we'll get here P and P gets cancelled, right? Because if we remove under root here, we'll get 1 by 2, means we'll get here, I will explain here, x minus 4 whole square plus y plus 3 whole square, right? Here we'll get whole square 1 by 2, and here we'll get again whole square. If we multiply this, we'll get 2 and 2 minus, and we'll get this only this value. Okay, now why all that why I have did like the direct method? It is very simple and we can understand it. Few people will not understand, so I have explained this in a long form. Okay, now we'll go to the problem. Now here what is P? PA is 5. No, we have now data squaring on both sides. What is 5 square? 5 square is 25. Now here we will directly write that x minus 4 whole square plus y plus 3 whole square is equals to, what is 5 square? 25. I hope you may all understand. Now here uh, we'll, what do you say, expand this. To expand this, we have a formula, a minus b whole square for this. Here a plus b whole square. What is a minus b whole square? A square plus b square minus 2ab. What is the formula for a plus b whole square? A square plus b square plus 2ab, right? Now here we will write x square plus 4 square minus 2 of 4 into x, or x into 4, plus here we have plus, no, here plus y square plus 3 square plus 2 of 3 into y, okay, which is equals to 25, right? We will solve here. X square plus, what is 4 square? 16 minus 4 into 2 8, x, okay, plus y square, 3 3s are 3 square 9 plus 3 into 2 6, here as it is y, which is equals to 25. Okay, now here we will write in a order. Here x square, this is done, plus y square, this is done. Here next minus 8x, this is done, plus 6y, this is done. If we add 16 plus 9, it is 25. Okay, these both are also done. Now which is equals to 25. If we take 25 here, we will get minus 25, plus 25 minus 25 gets cancelled. I have write this directly. Now we will get, that is x square plus y square minus 8x plus 6y is equals to 0. Therefore, the required equation is x square plus y square minus 8x plus 6y is equals to 0. Hence, we have solved this problem, and the answer is, and the equation or the answer for this problem is x square plus y square minus 8x plus 6y. Thank you for watching. Let us end this video, and in the next video we are going to continue the following problems. Thank you.